So we're still going to be focusing on slope a fair bit in this upcoming unit, but we're also going to be looking at the different formats of linear equations and doing a little bit more in terms of algebraic manipulation to go between different formats. We've already seen in the functions and relations section a little bit about the slope-intercept form of a line, y equals mx plus b. It's probably one of the most common formats that you will have seen in different classes in physics as well as in previous years in math. There's a couple of things about all these different formats that I just want to talk a little bit about. In terms of their equations, we do need to be able to identify which ones are the variables, the x and y variables. So your input is your x, your output is your y, in this case here. Your m and your b, m we've talked a little bit about, obviously. M is going to be your slope. And b is your y-intercept. And again, a y-intercept is a point on the graph 0, comma y. In this case, 0, comma b. It's a point on the actual graph. So you need to be able to identify that that value here translates directly into a point 0, comma b. Now, when we look at the point slope form, this one's actually based strictly from the equation for slope. Again, we need to have our input and our output. So the x and the y without the subscripts are your input and your outputs for what you plug in and out of and what you get out of the equation. Your m still is going to be equal to your slope, and your point that you would be given is x1, comma y1. So if you were given a slope and given a point, you could use this format to actually just come up with the equation of the line automatically. How this relates to the slope formula is that m normally is equal to your y2 minus your y1 all over your x2 minus your x1. If you isolate for all the y terms on one side, you multiply both sides of the equation by x2 minus x1, which crosses out here. And we multiply this side by x2 minus x1. So that is where it's ultimately coming from. It's mirroring this with your input x and y as a coordinate point. Now, standard form and general form, the textbook works more with standard form, but there is another one that other textbooks talk about too, which is referred to as general form. Standard form has it so that you have no fractions. Usually slope is written as rise over run, which means that it may not always simplify down to one nice number, an integer value. It may be left as a fraction. A and B and C in standard form are not fractions. So you have to make sure when you're working in standard form that if you're translating from slope-intercept to standard form, you have eliminated the denominator. So A, B, and C are integers. Same thing with general form. The only difference is we would isolate and move all the variables over to set the whole equation equal to 0. We'll be talking more about standard form a little bit more, just so you can see what it's like. And we're also going to look at examples of switching between the different formats and how to do it algebraically. So we're going to take a look at a couple of examples of how to do some of these conversions between the different formats of lines. We're going to start with the line. First of all, it's y equals 2 over 3x plus 6. We know automatically that this is a format we've seen before. We know that our m is now equal to 2 over 3. We also know our y-intercept is now 6, so we have a coordinate point 0, 6. So that tells us a little bit about the shape of the graph, where its y-intercept is, the slope of the graph, and we're pretty much okay to graph it from this point forward. Now we want to look at how to convert. Now standard form has it in the form of ax plus by equals some c value. A, B, and C are not fractions. So first we want to keep the constants on this side of the equation, which in this case my constant is 6. So if I have y equals 2 over 3x plus 6, in order to isolate from my 6, I need to subtract 2/3 x from both sides. Then I'll have y minus 2 over 3x equals to 6. So We usually want to have our x first, our y second. So we'll just switch the order. 2 over 3x plus y equals 6. After I switch the order, now I want to eliminate the fractions. Now remember, whatever you do to one side of the equation, you have to do to the other. So, in order to eliminate your denominator, we need to do something to both sides of the equation. In order to get rid of this 3, I'm going to multiply by 3 over 1. But we have to distribute. It has to go to both terms. And whatever you do to one side, you have to do to the other. So here I'll have technically 3 times negative 2 divided by 3 crosses out the 3, remains with negative 2. So negative 2x plus 3y is equal to 18. Now I have it in the form of a, which is negative 2, x, plus b, which is 3, y, equals to 18, which is my c. So a is equal to negative 2, b is equal to 3, c is equal to 18 in this example. Now when it's in this format of a line, it's not as easy to see your slope and your y-intercept. Whereas this format, it's quite nice to be able to read things off nice and quickly. The advantage of using this one really is to find your x-intercept and your y-intercepts by plugging in x comma 0 into the equation and not having to work with fractions. And to find your y-intercept, you plug in 0 comma y, and again, you don't have to work with any fractions. So if I was to find my x-intercept using this format, I would say negative 2 times my x plus 3 times 0, which disappears, has to equal to 18. Then I can say negative 2 has to equal to 18. Divide by negative 2, divide by negative 2, x is going to equal to negative 9. So there's my x-intercept. Didn't have to work with that many fractions besides the division here. A little bit easier to work with. Here, if I plug in 0 and y, same idea, negative 2 times 0 disappears, plus 3 times y is going to equal to 18. Divide both sides by 3, y is going to equal my 6. So I can find my x-intercept and my y-intercept using this format with less fraction work. That's ultimately the advantage of this format. So now here's another example. Now we're going to be working with the standard form and working into slope-intercept format. So, again, we have to be able to identify the format this is in. ax plus by is equal to c. So this is standard. Slope-intercept format is in the form of y equals to mx plus b. Now if you notice in this format we isolate for your y value. So we're going to use this equation 3x plus 2y equal to 16, and we're going to isolate from my y. So to both sides of the equation we're going to subtract 3x, subtract 3x. So we're going to have 2y is equal to negative 3x plus 16. Now I haven't totally isolated yet for y. So again, whatever you do to one side of the equation, you have to do to the other. In order to eliminate my 2, I'm going to divide by 2 or multiply by a half. 2 will cross out with 2, and then you're left with just y on that side of the equation. On the other side of the equation, now we have to, again, remember to distribute. So we'll get negative 3 times a half ends up being negative 3 over 2x plus 16 times a half. 16 over 2 becomes 8. Now in this format of the line, like we were just talking about before, this is my m value, so that means my slope is negative 3 over 2. It's going to have a negative slope, and my y-intercept, 0, 8. Here's another example of how to convert between different formats. So I'm now asking you to convert y plus 2 is equal to 3 over 2 times by x minus 4 into slope-intercept format. Now again, we have to identify what we're working with. This is referred to as slope point format, or point slope. ultimately what it's telling me is that this right here is my slope, and I have a point. The point is going to be based on 4 and your 2. Now the actual format of the line is based on your slope. Your slope is always the difference of the two. So keep in mind that's always going to be y minus y1 is equal to mx minus x1. So because I have the subtraction there, my point that they've given me is 4, and in this case here it's going to be y minus negative 2. So just looking at this equation format, I now know that I have a point at 4 and negative 2, and that my slope is a rise of 3 and over 2. So it's going to be something like that. Now they want us to get it into slope-intercept format, which is y equals mx plus b. So again, we're going to have to look at what they give us. Y plus 2, 3 over 2, x minus 4, and I want to get it into this format, which means again I need to isolate for my y, which is not too hard initially. I have to subtract 2 to both sides. So then y is now isolated, but yet this side is not quite in the right format yet. What I need to do is get mx plus b, just some constant. So we will need to distribute. 3 over 2 times x just becomes 3 over 2x minus 4 times that. So again, 4, 12, 12 divided by 2, that'll give us a 6 minus 2. Combine your like terms, and then combine the last terms to get minus 8. Now if we look at the graph here, we still have a 3 over 2 slope. Nothing's changed. So my m has not changed between these two formats. If your m changes between these two formats, you've definitely made a mistake. M does not change. Your slope is not going to change. It's an equivalent line. It's just changed the format of the equation. The y-intercept is down at negative 8, which makes sense. It's going to be somewhere down here, which is approximately negative 8. So this one makes sense. So again, we're looking at another conversion example, and this time we again have to identify what we're working with. This format here is your point slope. We can read the slope off directly as being 3 over 4. And we have a point that's given to us. Again, remember it's subtraction, so x minus your x1, which means you have a negative 2, because it's technically x minus negative 2, and y minus 6, so that is just 6. So point slope tells us the slope of the graph and a single point on the graph. We want to get into standard form. You want to have ax plus by equal to c. So we want to isolate for the constant, and our a, b, and c are not fractions, so we have to make sure that they're integer values. So again, start with what we know. And figure out how we get the constant by itself. Because we need the constant by itself, we are going to need to distribute. So y minus 6 is going to equal 3 over 4x plus 6 over 4, which reduces down to 3 over 2. Now that we get that, we now need to again isolate for all your constant values on one side and move all your x and your y's to the other side. So to both sides of the equation, we are going to move your negative 3 over 4x, so your variables are on the other side, and add 6 to both sides. We also need to make sure that we're not working with any sort of fractions. And I'm going to move these around so the x comes before the y. So negative 3 over 4x plus y And when we're working with these guys here, we need a common denominator.